Chapter 8. Fractions. Warm-up time. What is the fifth part of a foot? A toe. Learning time. We have already learned that a fraction is a part of the whole number. Let's imagine that you have one pizza divided into 8 slices. Writing fractions. Every fraction has two parts, a top number and a bottom number. In math terms, these are called the numerator and the denominator. Don't worry too much about remembering those names. As long as you remember what each number means, you can understand any fraction. Numerator 2, denominator 5. As you see in the picture, the bottom number or denominator is the number of parts a whole is divided into. In our pizza example, we said each slice was 1/8 of the pizza. The denominator 8, since the pizza was divided into 8 slices. The top number or numerator refers to a certain number of those parts. It lets us know how much we are talking about. Since we are talking about one slice of pizza, our numerator is 1. Let's look at another example. What if we divided the same pizza into 12 slices instead of 8? If we took one slice, that would be 1/12 of the pizza. One slice out of the 12 total slices. No matter what fraction you are trying to write, you always write it in the same way, with the number of parts on the bottom and the parts you are referring to on the top. Reading fractions. In the example above, if you had a pizza with 8 slices, each slice would be 1/8 of the pizza. You'd read that like this, 1/8. When you read or talk about fractions, we use special numbers called ordinal numbers. A good way to remember this is that many of them are the same numbers you use when you're putting things in order, third, fourth, fifth, and so on. You might know some of these numbers already. For example, when you tell your boss you'll be at work in half an hour, you're saying that you'll get there in 1/2 of an hour. If you're helping a friend bake a cake and she asks you for a third of a cup of sugar, you might know to hand her the measuring cup that says 1/3. Here are some of the most commonly used fractions. 1/2, 1/2. 1/3, 1/3. 1/4, 1/4 or a quarter. 1/5, 1/5. 1/10, 1/10. 1/12, 1/12. 1/100, 1/100th. 1/1000, 1/1000th. A good rule to remember is that most ordinal numbers end in th. So, 1/20 is 1/20th. 1/35 is 1/35th. 1/54 is 1/54th. What about fractions that don't have 1 on top? Read these as if you were counting. So if 1/5 is 1/5, then 2/5 is 2/5 and 3/5 is 3/5. The top number will always be a normal number like the ones you use to count, and the bottom number is always an ordinal number. Mixed numbers. Sometimes you might see a fraction next to a whole number. We call this a mixed number. Let's take a look at this example. 2.5. 21/2 is a mixed number. If we say we have 21/2 pizzas, it means we have 2 whole pizzas and half of another pizza. You can read 21/2 like this, 2.5. Let's try another example. What if you pour 1 whole cup of tea, then fill only 2 by 3 of another cup? You could write that situation like this. 1, 2 by third. You'd read 21 by 2 like this. 1 and 2/3. Remember, the whole number is always first. Whole fractions. So far, you have learned that a fraction is a part of a whole. For example, 3 by 4 means you have 3 parts out of 4 parts total. But what if you had a fraction like this? 8 by 8? In this example, we have 8 parts out of 8 parts total. If the total number and the bottom number of a fraction are the same, then the fraction is equal to 1. That's because you have every part of the fraction or one whole thing. This is sometimes known as a whole fraction. So, if you had 8 slices of pizza out of the 8 total, you'd have one whole pizza. 8 by 8 is equal to 1. Let's look at another example. 8 by 8 and 2 by 2. While these fractions may look different, they are actually just two ways of saying the same thing. Because these are whole fractions. 8 by 8 and 2 by 2 are both equal to 1. And because they are both equal to 1, they are also equal to each other. 8 by 8 is equal to 2 by 2. Thinking skills. Numerator. A numerator is the number in a fraction that lies above the line or vinculum. Denominator. A denominator is the number in a fraction that lies below the line or vinculum. Vinculums. A vinculum is a line that divides numerator and denominator. Activity 1. 1. Pick the right fraction out of 4 choices given. 1. 1 by 2, 3 by 2, 2 by 3, 1 by 3. 2. 1 by 3, 3 by 4, 1 by 2, 2 by 3. 3. 3 by 8, 5 by 8, 3 by 4, 2 by 7. 4. 6 by 5, 3 by 6, 2 by 5, 5 by 6. 5. 3 by 8, 6 by 8, 7 by 8, 8 by 7. 6. 4 by 6, 5 by 6, 6 by 5, 2 by 6. 7. 11 by 12, 7 by 12, 7 by 11, 8 by 12. 8. 5 by 9, 7 by 9, 6 by 9, 9 by 6. 2. Write the numerator and denominator for the following numbers. Fraction, numerator, denominator. 3 by 4, 9 by 5, 13 by 6, 19 by 5, 35 by 11, 45 by 12, 25 by 12, 41 by 12, 25 by 12. 3. Write the fractional number with the given numerator and denominator. Numerator, denominator, fractional number. 8, 3, 9, 4, 11, 5, 15, 7, 32, 8, 14, 12, 23, 7. Equivalent fractions. What do the fractions in example 1 have in common? Example 1. 1 by 2, 2 by 4, 3 by 6, 4 by 8. Each fraction in example 1 represents the same number. These fractions are equivalent. Definition. Equivalent fractions are different fractions that name the same number. The fractions 1 by 2, 2 by 4, 3 by 6, 4 by 8 are equivalent since each represents the same number. Let's look at some more examples of equivalent fractions. Example 2. 2 by 3, 4 by 6. The fractions 2 by 3 and 4 by 6 are equivalent. 2/3 is equivalent to 4/6. Example 3. 3 by 4, 6 by 8, 9 by 12. The fractions 3 by 4, 6 by 8 and 9 by 12 are equivalent. The fractions 3/4, 6/8 and 9/12 are equivalent. What would happen if we did not have shapes such as circles and rectangles to refer to? Look at example 4 below. Are the fractions 2 by 3, 6 by 9 and 8 by 12 equivalent? Explain why or why not. We need an arithmetic method for finding equivalent fractions. Procedure: to find equivalent fractions, multiply the numerator a and d, the denominator by the same non-zero. To find equivalent fractions, multiply the numerator and denominator by the same non-zero whole number. This procedure is used to solve example 4. Example 4. Are the fractions 2 by 3, 6 by 9 and 8 by 12 equivalent? Explain why or why not. Part A. 2 by 3 is equals to 2 into 3 by 3 into 3, which is equal to 6 by 9. Part B. 2 by 3 is equal to 2 into 4 by 3 into 4, which is equal to 8 by 12. Yes, 2 by 3 and 6 by 9 are equivalent, since the numerator and denominator of each fraction is multiplied by the same non-zero number. You can multiply the numerator and the denominator of a fraction by any non-zero whole number, as long as you multiply both by the same whole number. For example, you can multiply the numerator and the denominator by 3, as shown in part A above. But you cannot multiply the numerator by 3 and the denominator by 5. You can multiply the numerator and the denominator by 4, as shown in part B above. But you cannot multiply the numerator by 4 and denominator by 2. The numerator and the denominator of a fraction must be multiplied by the same non-zero whole number in order to have equivalent fractions. You may be wondering why this is so. In the last lesson, we learned that a fraction that has the same numerator and denominator is equal to 1. This is shown below. 2 by 2, 2 halves is equal to 1. 3 by 3, 3/3 is equal to 1. 4 by 4, 4/4 is equal to 1. 5 by 5, 5/5 is equal to 1. 6 by 6, 6/6 is equal to 1. Reducing fractions to lowest terms. Consider the following two fractions, 1 by 2 and 2 by 4. These fractions are equivalent fractions. They both represent the same amount. 1/2 of an orange is equal to 2/4 of an orange. However, only one of these fractions is written in lowest terms. A fraction is in lowest terms when the numerator and denominator have no common factor other than 1. The factors of 2 are 1 and 2. The factors of 4 are 1, 2 and 4. 2 and 4 share a common factor 2. We can reduce this fraction by dividing both the numerator and denominator by their common factor 2. 2 divided by 2 by 4 divided by 2 is equal to 1 by 2. 1 and 2 have no common factor other than 1. So the fraction is in lowest terms. Activity 2. 1. Write 5 equivalent fractions for each of the following. A. 4 by 5. B. 3 by 5. C. 2 by 7. D. 6 by 13. E. 5 by 11. F. 23 by 12. Write the equivalent fractions by filling in the space. A. 12 by 45 is equals to dash by 15. B. 14 by 65 is equals to dash by 21. C. 63 by 70 is equal to dash by 10. D. 56 by 80 is equal to 7 by dash. E. 49 by 56 is equal to 7 by dash. 3. Write the following fractions in the simplest form. 1 is done for you. A. 10 by 25 is equal to 10 divided by 5 by 25 divided by 5 is equal to 2 by 5. B. 12 by 25. C. 18 by 30. D. 3 by 60. E. 27 by 36. Types of fraction. Look at each fraction below. How are these fractions similar? How are they different? 1 by 4, 4 by 4, 7 by 4. The fractions above are similar since each one has a denominator of 4. Look at the circles below to see how these fractions are different. 1/4, 1, 1 by 4. 4/4, 4, 4 by 4. 7/4, 7 by 4. The fraction 1 by 4 is called a proper fraction. The fractions 4 by 4 and 7 by 4 are improper fractions. Definition. A proper fraction is a fraction in which the numerator is less than the denominator. Definition. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator. In example 1, we will identify each fraction as proper or improper. We will also write each fraction using words. Example 1. Fraction, type, words. 3 by 2, improper, 3 halves. 2 by 5, proper, 2 fifths. 3 by 5, improper, 3 thirds. 5 by 6, proper, 5 sixths. 11 by 8, improper, 11 eighths. 8 by 8, improper, 8 eighths. Thinking skills. The LCM of the denominators of two or more unlike fractions is their common denominator. What do the fractions in example 2 have in common? Example 2. 2 halves. 2 by 2 is equal to 2 halves. 3 by 3 is equal to 3 thirds. 4 by 4 is equal to 4 fourths. 5 by 5 is equal to 5 fifths. 6 by 6 is equal to 6 sixths. In example 2, each fraction has a numerator that is equal to its denominator. Each of these fractions is an improper fraction equal to 1 whole 1. An improper fraction can also be greater than 1 whole as shown in example 3. Example 3. 7 by 4. In the improper fraction 7 fourths, the numerator 7 is greater than the denominator 4. We can write this improper fraction as a mixed number. Definition. A mixed number consists of a whole number part and a fractional part. In examples 4 through 6, we will write each improper fraction as a mixed number. Example 4. Write 7 by 4 as a mixed number. 4 by 4, 3 by 4. 7 by 4 is equal to 4 by 4 plus 3 by 4. 7 by 4 is equal to 1 plus 3 by 4. 7 by 4 is equal to 1 into 3 by 4. In example 4, 7 fourths is an improper fraction. It is really the sum of 4 fourths and 3 fourths. 7 fourths is written as the mixed number 1 and 3 fourths, where 1 is the whole number part and 3 fourths is the fractional part. Example 5, write 7 by 3 as a mixed number. 7 by 3 is equal to 3 by 3, plus 3 by 3 plus 1 by 3. 7 by 3 is equal to 1 plus 1 plus 1 by 3. 7 by 3 is equal to 2 plus 1 by 3. 7 by 3 is equal to 2 1/3. In example 5, the improper fraction 7/3 is written as the mixed number 2 and 1/3, where 2 is the whole number part and 1/3 is the fractional part. Example, write 17. Example 6, write 17 by 5 as a mixed number. 5 by 5, 5 by 5, 5 by 5, 2 by 5. 17 by 5 is equal to 5 by 5 plus 5 by 5 plus 5 by 5 plus 2 by 5. 17 by 15 is equal to 1 plus 1. 17 by 5 is equal to 1 plus 1 plus 1 plus 2 by 5. 17 by 5 is equal to 3 plus 2 by 5. 17 by 5 is equal to 3, 2 by 5. In example 6, the improper fraction 17/5 is written as the mixed number 3 and 2/5, where 3 is the whole number part and 2/5 is the fractional part. Comparison of unlike fractions. If denominators of the given fractions are different, then those fractions are unlike fractions. How to convert unlike fractions into like fractions? 1. Find LCM, lowest common multiple for the given fractions denominators. 2. For each of the unlike fractions, do the following steps. New denominator is equal to LCM of the denominators. New numerator is equal to multiply the numerator by the quotient from dividing the LCM by the denominator of the unlike fraction. 3. After step 2, all the unlike fraction will have the same denominator, LCM, or unlike fractions are converted to like fractions. Example, convert 1 by 6 and 3 by 8 into like fractions. LCM for 6 and 8 is equal to 24. Adjust numerator to the LCM 24. Convert 1 by 6. Numerator to be multiplied by 24 by 6 is equal to 4. New numerator 1 into 4 is equal to 4. 1 by 6 is equal to 4 by 24. Convert 3 by 8. Numerator to be multiplied by 24 by 8 is equal to 3. New numerator is equal to 3 into 3 is equal to 9. 3 by 8 is equal to 9 by 24. Result, 1 by 6 and 3 by 8 is equal to 4 by 24 and 9 by 24. How to compare unlike fractions using LCM? 1. Convert unlike fractions into like fractions. 2. The fraction after converting into like fractions which has the biggest numerator is the biggest fraction among the given fractions. 3. If 2 or more fractions have same numerator, then those fractions are equivalent fractions. How to compare two unlike fractions using cross multiplication? 1. Multiply the numerator of the first fraction with the denominator of the second fraction. Result is value 1. 2. Multiply the numerator of the second fraction with the denominator of the first fraction. Result is value 2. 3. If the value 1 is greater than the value 2, then the first fraction is bigger than the second fraction. 4. If the value 2 is greater than the value 1, then the second fraction is bigger than the first fraction. 5. If value 1 and value 2 are same, then both the fractions are equal. Example. Compare the fractions 2 by 3 and 4 by 5. Value 1, 2 into 5 is equal to 10. Value 2, 4 into 3 is equal to 2. Since 12 is greater than 10, value 2 is greater than value 1, so 4 by 5 is greater than 2 by 3. Addition of like fractions. While adding like fractions, we add the numerators together and write the sum over the same denominator. Points to remember: 1. For convenience, change the fractions to the lowest form before adding or subtracting. 2. Write the answers in the lowest form. 3. Change into mixed fractions if the answer is improper fraction. Sum of fractions is equal to sum of like fractions by common denominator. Example 1. 4 by 5 plus 2 by 15. Add the following fraction. Solution: the LCM of 5 and 15 is 15. Therefore, 4 by 5 plus 2 by 15 is equal to 12 by 2 by 15 is equal to 14 by 15. We changed 4 by 5 to 2 by 15 by saying 5 goes into 15 3 times. 3 times 4 is 12. We did not change 2 by 15 because we are not changing the denominator 15. Example 2. 5 by 6 plus 7 by 9. Solution: the LCM of 6 and 9 is 18. 5 by 6 plus 7 by 9 is equal to 15 plus 14 by 18 is equal to 29 by 18 is equal to 1. We changed 5 by 6 to 15 by 18 by multiplying both terms by 3. We changed 7 by 9 to 14 by 18 by multiplying both terms by 2. Find the value of A. 3 by 4 of 16. B. 2 by 15 of 30. C. 7 by 21 of 48. D. 4 by 5 of 45. Word problems. 1. Raju and Peter bought a large pizza to share. Raju ate 5 by 8 of the pizza. What fraction of the pizza was left for Peter? 2. Mrs. Bloom baked a cake. She ate 1 by 12 of the cake and gave 7 by 12 of the cake to her neighbor. What fraction of the cake was left? 3. Monica and Ryan shared 18 cookies. Monica ate 1 by 6 of the cookies. Ryan ate 1 by 3 of the cookies. How many cookies were left? 4. You go out for a long walk. You walk 3 by 4 mile and then sit down to take a rest. Then you walk 3 by 8 of a mile. How far did you walk altogether? 5. A school wants to make a new playground by cleaning up an abandoned lot that is shaped like a rectangle. They give the job of planning the playground to a group of students. The students decide to use 1 by 4 of the playground for a basketball court and 3 by 8 of the playground for a soccer field. How much is left for the swings and play equipment? 6. You have 10 cookies and want to give 1 by 2 of them to a friend. How many do you give to your friend? 7. 5 friends buy a package of 12 cookies and want to share them equally. Each friend will get 1 by 5 of the cookies. How much will each friend get? Maths lab activity. Help the baker to match the cut portion of cake. Fraction fiddle. Matching cake fractions. Hi, I'm Fran. I fill order for cakes. Not everyone wants a whole cake, so I have to make the cake and the order match. Have you helped me to do this? Yes? No. Predict order. 1 by 4, 1 by 3, 1 by 2, 5 by 4. Find the value of A. 3 by 4 of 16, B. 2 by 15 of 30, C. 7 by 21 of 48, D. 4 by 5 of 45. Word problems. 1. Raju and Peter bought a large pizza to share. Raju ate 5 by 8 of the pizza. What fraction of the pizza was left for Peter? 2. Mrs. Bloom baked a cake. She ate 1 by 12 of the cake and gave 7 by 12 of the cake to her neighbor. What fraction of the cake was left? 3. Monica and Ryan shared 18 cookies. Monica ate 1 by 6 of the cookies. Ryan ate 1 by 3 of the cookies. How many cookies were left? 4. You go out for a long walk. You walk 3 by 4 mile and then sit down to take a rest. Then you walk 3 by 8 of a mile. How far did you walk altogether? 5. A school wants to make a new playground by cleaning up an abandoned lot that is shaped like a rectangle. They give the job of planning the playground to a group of students. The students decide to use 1 by 4 of the playground for a basketball court and 3 by 8 of the playground for a soccer field. How much is left for the swings and play equipment? 6. You have 10 cookies and want to give 1 by 2 of them to a friend. How many do you give to your friend? 7. 5 friends buy a package of 12 cookies and want to share them equally. Each friend will get 1 by 5 of the cookies. How much will each friend get? Maths lab activity. Help the baker to match the cut portion of cake. Fraction fiddle. Matching cake fractions. Hi, I'm Fran. I fill order for cakes. Not everyone wants a whole cake, so I have to make the cake and the order match. Have you helped me to do this? Yes? No. Predict order. 1 by 4, 1 by 3, 1 by 2, 5 by 4.